There are 24 different possible ways in which you can arrange 4 different colored balls. For 3 different colored balls, it is 6. To arrange 2 balls, there are only 2 possible ways. That is, switching either of the balls to the front or back. Ways of arranging one object are rather simple, since there is only one way to arrange one object. But 0 objects, well, that is the problem. How many ways can you arrange what you can't see? Why is 0 factorial equal to 1? Factorial of a positive integer n is the product of n and all the positive integers below it down to 1. But 0 factorial, it does not follow this rule, since it is not a positive integer and therefore its value must be defined separately in a way that keeps the pattern consistent. So what should 0 factorial be? Is it okay for it to be 1 or 0? If 0 factorial were equal to 0, then 1 factorial would automatically be equal to 0, and at the same time 2 factorial would be equal to 0, and eventually n factorial would be equal to 0. That would destroy the consistency of factorials and make them useless. What if 0 factorial is equal to 1? Then 1 factorial will be equal to 1 and 2 factorial will be equal to 2, and so on, which are actually true. In combinatorics, the number of ways in which you can select R object from n objects is denoted by where n is the total number of objects that can be selected from and R is the number of objects that is to be selected. How many ways can you select 4 balls from a group of 4 balls? Practically, there is only one way to do that, by selecting all the ball. Using combinatorics, 4 combination 4 equals 4 factorial divided by 4 factorial times 4 minus 4 factorial, which is equal to 1. 4 combination 4 can only be equal to 1 if this formula remains consistent, which requires that 0 factorial equals 1. In mathematics, every operation has a neutral element, also called an identity, which does not change a value when applied. For addition, this identity is 0 because adding 0 to any number leaves it unchanged. For multiplication, the identity is 1 because multiplying any number by 1 does not alter its value. A factorial is defined as a product of consecutive positive integers. For example, 3 factorial equals 1 times 2 times 3, 2 factorial equals 1 times 2, and 1 factorial equals 1. This shows that factorials are built through repeated multiplication. Since factorials are products, they must begin with the multiplicative identity, which is 1. This ensures that the value of the product is preserved as the multiplication proceeds. If factorials were to start from 0 instead, every result would become 0 because any number multiplied by 0 is 0. For instance, 0 times 1 times 2 times 3 is 0, which contradicts the correct value of 3 factorial, which is equals to 6. Therefore, the presence of an invisible 1 at the beginning of every factorial is essential. It reflects the identity property of multiplication and ensures that the factorial produce meaningful results. This also explains why 0 factorial equals 1, since multiplying no number at all must yield the multiplicative identity. When we reach 0 factorial, we are asking for the product of all positive integers less than or equals to 0. There are no such numbers. This is an empty product. In mathematics, an empty product is defined as 1 because 1 is the identity element for multiplication. It is a blank canvas of multiplication.